Hello, welcome to DataSeries. DataSeries is an initiative of Data Lab where we learn analytical concepts and techniques that are challenging for data professionals, entrepreneurs, or going into data analytics or wanting to understand how to apply data analytics to what they do. Also, Data Series is one of those initiative or one of those programs on Data Lab, where we feature professionals, industry experts who have knowledge of data analytics and data science to solve problems. Today is one of the episodes on Data Lab, and I will be your mentor. My name is Amaefule Timothy, and I will be your mentor on today's episodes on Data Lab on Data Series. Yes. Now, let's talk about what today's episode is going to look like. So, okay. All right. Today's episode, we're going to look at a very important concept in data analytics, which is database and relational database with its language, SQL. Now, first, let's look at the things we're going to learn today. Tonight, we're going to learn a couple of things. First, we're going to start with understanding or looking at a bit of an history on how database have evolved. Okay, and then we will also look at the core difference between relational database and non-relational databases, which are the two types of database that we have. And then we'll go deep into SQL, and we will also learn how to use SQL to query data, manage data, and as well how important it is to the entrepreneur or to the business, the organization at large. Then we will look at a case study that allows us to understand how to actually run SQL to your program. Now, let's get into the lesson itself. Let's start with a bit of an history on database, shall we? Now, database started quite a number of centuries ago. We're looking at in the 1960s. That was where all this started. In the 1960s, data was primarily in files. You know how you have files on your PC, yeah? Basic local disk file, local drive files, include your documents, your music, your pictures, your videos. Now, let's start with just the document. Now, early in the 1960s, the need to save files was important, was growing, yes, was becoming demanding. And because of that demand, the need to create a system that could save and store these files was important. But there was a problem with that century. There was a problem with that era when it comes to database, and that was the fact that the data were duplicated. So they were struggling with data duplication in a concept where you could see a storage that have the same files. So I put the same files, a friend put the same files. Both worked on the same file, but in the storage is duplicated. So there was a problem of duplication. There was also the problem of inconsistency, right? The files was not consistent, and there was also the challenge of retrieving that data from that database, which was really a challenge for them back then. And there was a lack of centralized data control, centralized layout to have access to every single data that goes in and out of that database. That was a problem for them. They solved it. We came to 1970s, the need for relational database came in. And there was this model that was being used, that was being developed back then. It was called the EF codes relational model. This model was designed to help us, to help that system as at then in the 1970s, understand and manage relational database. That was when relational database came into the concept, came into the picture. So relational database was a very important feature database for that system in the 1970s. And this was because relational database refers to the concept of tables. In a table, an individual will have a name, will have a gender, will fall on a particular location, and will also have an age. Now, those information relates to a person, as another person will have the same information. So there's this consistency with the data, and the data are stored on a table. So because of that whole amazing structure to be able to organize data, that was why relational database was very important. Okay, and so the knowledge to be able to use SQL to interact with that data that is in a relational database became important too. So that was when SQL was introduced as structured query language. Back then it was called SQL. And then because they found out that there was a car company that was also called SQL, and so the name was renamed as SQL. Okay, so but if you call it SQL, it's still the same. If you call it SQL, still the same. So this language was built, designed to manage relational database, meaning if the data is not relational, then SQL won't be able to manage that data. Amazing, right? Let's look at our world today. In our current society, in the current stage that we are in technology, what are we looking out to? What are we looking out for? Now, currently, we are in a phase of cloud-based storage, which is amazing. Big data storage technology. Okay, these storage platforms go across companies like Microsoft, Google, and these guys, they have platforms like Azure. Azure is owned by Microsoft, it's a cloud based storage. Amazon, we're the ones that own AWS, which is web storage, web based service. Okay, and then we have um, Google Cloud. Google Cloud is also a big data technology, and it's built, designed, and managed by Google. Now, these guys are at the forefront of cloud technology, and with all the infrastructures that are being put in place, technologies evolving, there's no better place to store your data if not in the cloud. Now, but if we look at a projected future from now, we're looking at a time where AI will be empowering the cloud, and then we will have cloud empowered AI or AI empowered cloud. Okay, cloud empowered AI, meaning the cloud platform will be empowered by AI to manage massive data sets and support predictive analytics, meaning we'll be able to predict the next data that can be valuable to the storage or valuable to the company in the database using AI, meaning the database, the cloud technology will be empowered by AI to do this. And I think we're already getting the hang of it, because some technology out there are already taking a thought into this and deploying AI into all of these cloud bases. Well, I think all this is amazing. But let's come back home, which is SQL. How can we use SQL to do all this? So for you to understand SQL, you first need to understand database. So let's start with an understanding of what database is. First of all, let's have an understanding that database is an organized collection of structured or an unstructured data. Okay, so when I say data is structured, it means that the data is arranged, is placed in variables, in categories. Okay, it has fields and entries. The fields are the columns and the entries are the rows. All right, unstructured data is a text file, your notes. When you write a note and your notes just look like spaces, line by line, that's an unstructured data, right? Because it cannot be arranged in rows and columns. So that's an unstructured data. So whether the data is structured or unstructured, database collects all of those data, right? And the reason for that is so that we can be able to access that data. Okay, we can be able to manage that data. We can also update the database when new data are being generated. Now, it becomes important for us to understand the importance of database in organization, in systems, in businesses. First thing is, with database, there is an efficient storage, meaning the storage is enabled, meaning you don't have to worry about, oh, what if I need this data? You know where all the data are going to be stored, so it's always easy to retrieve that data. That's very, very important. Second thing I would mention as an importance to database is the fact that it supports real-time data processes and analysis in our modern society, right? In our society today, because one is, if there's a real-time data, let's say the data that goes from social media, data of people interacting with the website, data of customer feedbacks, and all of those information that goes on the internet, that data is trapped into the database. It goes straight into the database, and thanks to the data engineers in the company that have designed the pipelines, how that data will move from the website, from the platform to that database. Thanks to these guys, we can be able to process that data and extract insights from it, analyze that data on real time, and give the business real time report. And I think that's just amazing, because if you can do that, I think you become a very valuable person to the organization. Pretty much, right? Let's talk about some real world examples. In Google, these data comes from the search engine. Okay, so the search engine are the interface where the data is being collected, and while we search on the search engine, the data is is extracted from the database and is popped up to the users. So the users can see the results of that data, but the data came from a database. Okay, and then we also have user profile. So while we are on Google and we are putting informations there, while we are looking for people's information and putting people's information on the internet, all those things go to Google. So Google stores those data, and the data can be retrieved, and the data can be added, and the data can be updated. Let's talk about Amazon. These guys, which is a very large and robust system for e-commerce. The way they manage their data is just pretty amazing, because they have like lots of product listed, transaction going on the website, and lots of customers with customers preference. So they arrange all this data in a structural form, and of course with SQL, which is which is the language for relational database. This data can easily be retrieved, managed, and as well used for the right reasons. Now, let's talk about Facebook. Facebook, social media. I use Facebook as an example of all the social medias out there. Okay, so Facebook, of course, every social media will have users and their profile, will have activities for logins. That's activity logs, how you log in, how you log out, when you're active online, when you're not active online, connecting users from one user, recommending who's connected to you, who's related to you, mutual friends, and all that. Almost all social media does that, recommending who to connect with you on that platform. That's because there is already a database of people, and the connection between these tables is how the social media is able to recommend, oh, this person that has a similar location with you, I think this person will be a good friend. Probably you know this person, so they recommend you to that person, and you're like, hey, I know this guy. And I think that is one of the beauty of database. Now let's move on to talk about some more interesting things. Type of database. Okay, now there are two types of database. There's relational database, and then there's non-relational database. Okay, I started already to talk about relational database, a bit of it, but I'm going to talk more about it. Let's talk about relational database. In relational database, we're looking at an organized data in tables. Okay, so tables have rows and columns, and that data fits on that table. So you have a table with rows and columns. The rows are referred to the entries or records, while the columns are referred to the fields or the variables. And that's the beauty of a relational data. Okay, now with relational database, it supports lots of features like key, for example. And we know that a key is the connector to a table. Every table has a primary key. That's the word, primary key. Now there are two types of keys. Let me start from that. There's two types of keys. There's a primary key, and there's a foreign key. Sorry. There's a foreign key, there's a primary key. Every table has a key. What's a key? A key is like a unique identifier, or a serial number, or a unique number assigned to a particular record on the table in the database. Okay, so it becomes important to know that with a relational database, keys, which is the unique identifier of records, are created in that table. So every table has a key. But the key of a table in another table, that's a foreign key, because that's a foreigner in another table. Foreign. Okay, so that's just the logic around it. Now, some DBMS, or better to say, some application that we use to interact with a relational database include MySQL or MySQL, PostgreSQL, Oracle, Microsoft SQL Server. These guys are open sourced, and they're out there for you to use to be able to manage your organization or understand how to create a system for a database. Let's talk about non-relational database. Although this program or this class, sorry, is mainly focused on relational database, but I'll still talk a bit about it so that you're not in any way missing out. Okay, so let's talk about non-relational database. The language that we use to interact with a non-relational database is NoSQL. The way we have SQL for relational database, that's the same way we have NoSQL for non-relational database. Now let's understand better what a non-relational database really is. Okay, a bit about it. So a non-relational database, it allows flexible schema. What is flexible schema? The structure, the data don't have to be structured. So as long as this data has information that are important and identified and recognized, then you can always flex the schema, meaning the schema supports structured or unstructured. Sorry, the schema support unstructured or semi-structured data. Okay, so semi-structured, a bit of it is structured, but still not like completely structured. So you still have to do some structuring on it. And if you don't want to do some structuring on it, you still use the data that way. NoSQL would definitely be your language for a non-relational database. Non-relational database means that the data is not in rows or tables. It's not in rows and columns. It's not in table. It's just the way it is. Files. It's just a document, like your notebook where you jot down stuff. You don't really lie when you're writing a note, do you? You don't do that, right? So that's the beauty of a non-relational database. Okay, so the data that we stored in non-relational database, they could be key value data. Okay, so we have a key and we have the values. So the example of key value would be name. Now you see like lots of names. Okay, so name, and then you see David, you see parents, and you see the parent's name. You know, just like your dictionary. Let's just use dictionary for example. In your dictionary, you have the word and you have the meaning. Yeah, that's it. That's a perfect way to understand key value. So there's always a name to search in a dictionary, and then there's the information that dictionary gives you, like the name of the meaning of that word, its, you know, its grammar, its pronunciation, and all that. So non-relational database can hold such data, including your data in a document. Okay, the data that is, if you scrape the data from the internet, that data is going to be a unstructured data. So that's it. And then a graph data. Look at the graph that we have in, you know, cryptocurrency. All those charts that are reading, they are non-structured, they are non-relational database. Okay, so they are unstructured data. And so it becomes a means of, it's very important that the data is being stored. Some platforms that allow us to use unstructured data would include MongoDB, because MongoDB is a very comfortable and, you know, a comfortable environment to use to interact with a non-relational database. We also have Cassandra and we have Redis. These guys are different platforms that allows us to interact with non-relational database. So the question now becomes, when do we use these guys? We use a relational database when the data is structured. So first, is the data structured? Tick. Is there a relationship between the entries? That means if we look at the data, can we pattern it? Is there a pattern here where the name, oh, this is the name of a person, oh, this is his age, oh, this is his gender, oh, this is his, you know, location. And then we look at another data and we see the same thing. Oh, this should be his name, this is his gender, oh, this should be his age. When we see a pattern in the data, then that data has a relationship, and that information would best be on a relational database. Okay, now for a non-relational database, the moment the data is unstructured, if the data is a very large scale, like it's a big data file, come on, if the rate at which the data is being processed is fast, meaning the source of the data is like real-time data, is being processed on a very high frequency, data from social media, data from, you know, IoT devices, data that are coming from our social media posts and uploads, then those data definitely are unstructured. They should go to a non-relational database. Pretty interesting, right? That's because data are very important and data needs to be stored, and the storage needs to be selected carefully. And so all these things should be considered when you're working with the data. Now, let's look at relational database, because that's the whole purpose of this course or lesson. So let's understand what a relational database. First, I'm going to start with explaining some core concepts. Okay, first I'm going to start with explaining some core concepts. I'm going to talk about tables, then I'll talk about keys, two types of keys. Of course, I mentioned it earlier, primary, the foreign, and then I'll talk about relationship. So first, I've talked about a table as rows and columns. Okay, let's talk about primary key. I talked about it, but I'll still talk about it more to lay emphasis. Like I said, these guys, they are unique identifiers. Okay, they are assigned to each record. Don't forget, records are your rows. You might be wondering what's rows column. Rows, just like when you're rolling a ball, right? You're going horizontally, that's rolling your ball. But if you know horizontal, which is rows, then know that vertical is column. So that's how to know rows and column. I know that can be a little bit challenge to remember. Okay, so your primary keys, they are the unique identifier that are marked to every record. So every record in your table has something that is unique. It's possible to find an information of the same person. I mean, two people having the same name, having the same location, having the same age, and funny enough, having the same hobby. So you don't want to get it all mixed up in your database. So that is the reason to introduce a primary key. I think that makes enough sense. Let's talk about foreign keys. So you know how you have two data, customers and products, and you want to connect customers with the product to say, okay, these customers bought this product. Or say you want to connect the product and the transaction. So you want to say this customer, this was the transaction that led to this was the product that was bought for this transaction. So that way you will be able to understand better how the wholesale system works. Foreign keys. So foreign keys are the key of a table, or better still, foreign keys are primary key in another table. Okay, so the way we have two tables, customers and products. Customers have their own key, products have its own key. Okay, so if we put a customer ID in the product table, that customer ID in the product table becomes a foreign key to the product table. Do you get? So the moment we can transfer a ID, which is a primary key, from one table to the other table, and the table is in another table that it doesn't relate with, then that table is holding a foreign key. Makes sense, yeah? All right, let's talk about relationships. So relationship is just the connections between two or more tables, okay? So tables can be related through keys, and that key is meant to help for data integrity. So we can trust the data because we don't have to put all the information in one place. The data are in different tables, and we can connect one table to two tables to three tables, all because there's a concept of relation. You can read more about relationship. Okay, in relationship we have one to one, one to many, we have many to one, and we have many to many. Okay, so these are the different types of relationship that are out there. And so this brings us to the language itself, which is SQL. Of course, at this point, you know the full meaning of SQL. So SQL is majorly used to define the data in the database. It's also used to query the database. You know, it's used to update the data. It's also used to create the table. You can also use SQL to create the table. All right, you use SQL to even create the database depending on the DBMS, RODBMS you're using. Okay, so DBMS means database management system, and RODBMS means relational database management system. Because we're talking about relational database, so we need to mention the RODBMS. Makes sense, yeah. Okay, so let's move on to talk about a case study. Now, imagine that you had a financial database where they store information like the customer details, and the account information, and transactions that happen. So you have a table. Let's say, for example, three tables. Customer table will contain the name of the customer, the location of the customer, the job description, or the role of the customer, like what does he do. You also have the customer gender, you also have the customer age. Yeah, so all these records, all these fields, they will be in the customer table. So we have the accounts table, and then we have the transaction. So that's three tables. So these three tables are in the financial organization database. So that's one database having three tables. One database, three tables. Okay, now let's pick one table, which is the customer table. In the customer table, there is a particular column that is unique. That's a unique identifier, and that column is referred to the customer ID. Okay, because that's the key, that's the primary key, that's the key we're going to use to identify unique customers, row wise, record wise, entry wise. Okay, and then we have the foreign keys. So if the customer table was found in the transaction table, meaning we're saying this customer transacted with this application on Tuesday, the 1st of September, then that means that particular role, that particular information of the customer ID in the transaction table refers to a foreign key. Pretty fun, right? Pretty interesting too if you visualize it with your head. Okay, so let's look at the whole idea with NoSQL. So why NoSQL at the first place? Why should we embrace NoSQL if we were given an unstructured data? First, the beauty is it's scalable. Okay, non-structured, I mean, NoSQL is scalable, meaning you can always use it in any platform. If you're building a website, you need a NoSQL so that the data can be trapped. If you're building a mobile app, you need a NoSQL platform. That's why a lot of developers choose MongoDB and Cassandra, especially big data platforms, and also websites. So mobile apps, mobile devs, they know this better. Now, because the data is unstructured and the data changes, the data changes so fast. So you want to create a platform or a technology that can withstand whatever changes or whatever happens to the front view of that data. Now, some of the data that can be stored in using NoSQL database, like key value database, of course, will be Dynamo DB, that's database. Then we have Redis. But if the data is a document, if it's a document data, usually a JSON file or an XML file, then MongoDB is your guy, or Couchbase or MongoDB. But if the data is a column base, if the data is a column base file, you want to optimize the heaviness of that data, operational data, and you also want to create a structure for that heavy data. Then of course Cassandra is your guy. Cassandra works best with column-based storage, stored column-based data files. Okay, so Cassandra can read heavy data. In fact, if you're building on big data platforms, then Cassandra is your guy. Cassandra is your guy. Let's talk about graph database. So if you're working with a data that has to deal with nodes and edges, meaning it stores entry and relationship between two or more informations in the database. Okay, so definitely like forex data, crypto data, these data are graph based. So Neo4j will be your guy. I mean, I'm just talking about some of the DBMS, that's database management system, that can leverage on the nature of the data. So based on the nature of the data will determine the kind of database to choose. That's just very, very important. Now, let's look at an example of a social media platform. Okay, so a NoSQL database will definitely store user activities and their posts, interactions on posts, and engagements. When the data is highly unstructured, and relationship between friends and followers and likes and comments and posts. All of these data, you see, they're not structured. So with all of these data going in the social media, of course, that there are going to be a lot of changes. You could put a post up, you could take it down, you could just move from, I don't know, someone can just search for your name and find you and connect with you. How does that happen? So you need a database that is very flexible and scalable. And social media data, definitely SQL. NoSQL is your guy. All right, so now we have an idea of all the different types, which is relational and non-relational. Let's get to understand the language itself, which is relational database, SQL, the essentials of SQL. Now, in SQL, there are some keywords, there are some words, some language. It's a language, of course, and every language have its keyword. Every language has its dialect. So let's speak in the language of SQL, shall we? There's something called commands, SQL command. SQL commands are words that we use when we want to carry out a particular action. If I want to ask you, if I want to be polite to you, what will I say? I'll say please. right? I'll say, please, can you? So what's like, can you do this? What's like, please? What's like, I'm sorry? These words, they are like commands in human language that allows us to be polite with people. Okay. So something like that is also reflected in SQL. Now let's look at some SQL commands like the select statement, the insert, the update, delete. Okay. So with the select statement, we can retrieve the data in the database, which is awesome. And with the insert statement, we can put new data in a table. With the update statement, we can always modify the data in the database. So if we want to change the name of the particular user, then update will be our guy because it will modify that data that is in the database. And if we want to remove a particular data, of course, delete is your guy. Now, very important to know, say for example, we want to filter all the customers' name in a particular table, let's say customer table, and we only want to filter the customer name. So what would we do? We will say select then the customer name, which is the column in that table, and then we'll refer to the table, which is from then the table, and then it will be selected. All right, some other advanced commands includes join and conditional, such as filtering your results using the where clause, or some other advanced concepts that you will also be learning when we get into the hands-on. Now let's look at the case studies. If it was a financial institute, now say for example, we want to work with a financial institution and we've chosen the database. Now, first thing, you need to choose the kind of database that you want to build this data on, because financial institute, their data are structured, right? Look at your banks. The bank, their data is structured. There is customer, there's a record, and all that. So first, we're going to choose to build this database with SQL, or we're going to interact with this database with SQL because it allows us to be able to manage customer data. It allows us to be able to manage transaction data. It allows us to manage compliance audits. Okay. Now, it's very important because the data will be definitely accurate if we follow the structure of the table. The data will be consistent. Okay. And then, of course, the data will be secured. There's a good security of data in SQL. Okay, so you will explore that. So let's come back to the stock. So let's use a stock trading platform that uses SQL to manage real-time data reports. So they'll be using SQL to query the large set of trade data, and that data will be producing daily reports. They'll be using that data to get daily reports. So they'll be able to know how the trading is going, what are people doing, who's logging in, who's not logging in, and all that. So that's just the beauty of, SQL to a financial institute. So at the end of the day, we're looking at a high reliable and accurate transaction database management. So the data management system of such platform will be accurate because they build a structure for the data, which is the database. Let's look at another case study, which is a health. In the health industry, why should they consider a database? One is patient records. They want to be able to keep patient records in a very organized way, keep medical history of activities that have happened in the past, okay, of people's that have been diagnosed and all of that. They also want to keep record of the treatments that they recommend or diagnose to customers, to patients, sorry. So they want to keep that record, and also insurance details. Okay, so you want to have all of those records. So with a relational database, of course, these data will be consistent because over time they will keep it consistent. They'll be consistent with that record. They will follow through with the records in that table, and it will make all of the data very easy to be accessible, readable, and as well manageable. Okay, so in a hospital, they will be using SQL database to maintain the data, up-to-date patient information, and as well, the doctors can use that data to prescribe the right treatment. Imagine the doctor is looking at the database to say, okay, so this is what I recommended to you the last time you were here and the last 2 times you were here. So I can now predict the next thing, how your treatment is going. But if they don't have that data, then they will ask the user, so what were you treating the previous time? And the user will lie. And if the user lies, the doctor will prescribe what the patient, the rest. They said the rest is history. So key benefits of using a database for a medical center definitely will be for patient safety. You want to treat things with a lot of safety in the medical sector, and you want the record to be efficient. So you want to manage that record efficiently and as well with a lot of caution. Let's go to an e-commerce or an academic setting. Okay, I'm mentioning all these cases so that you can understand how this applies to the industry. And industry understanding is very important. It will take you a long way, and it will bring out a lot of beautiful things that you did not know about that concept while you were learning. All right. Now, in an e-commerce section, why would they choose an SQL first? They use an SQL to be able to structure their data like products, catalogs, the orders that are taken, and the transaction that happen in the business. So SQL will be their guy. But if they choose no SQL, then they should look at, is the data unstructured, okay, such as user behaviors, recommendation system to refer to them, what product to buy, and reading reviews, collecting those reviews of customers. Of course, this kind of data, they can be structured, user behaviors, recommendations, review. This data can be structured, so they need to be in an unstructured database, which is NoSQL becomes the language. That's one e-commerce section. Let's look at a academic section. Academic section, any of these guys can choose to use an SQL or a NoSQL depending on the kind of data that they are getting. The data define your database. I'll say it again. Your data define your database. So if you don't understand your data, then your database will, definitely will not serve this purpose. So you need to understand your data so you can be able to serve its purpose. All right, now let's look at a academics. I've not talked about academics so well. Now, one thing about academics data is most times we want to keep a structured record of students, their name, their age, their date of birth, better, their gender, their preferred course and all that. So you want to keep all of that as a record. There's also the grading system, because you're going to be mapping students with their course with the grading system. So you see that connection between that. So how are you able to grade a particular student on a particular course with a particular system? That's because the data is in tables, so you can be able to connect this data. You just connect them together. And that's a relationship, right? That's what I've been saying since, relationship. So SQL is a structured platform, is a language for managing structured data. But what if the data is not structured? Okay, so we're looking at research data, we're looking at documents or files, like hundreds and thousands of files. All of those data, they're not structured. So you want to put them in a non-relational database management system. So NoSQL will be your guy in that kind of data. So the data define your database. Okay, so Amazon will combine both SQL and NoSQL to solve their problem. They'll be using SQL to take orders and manage the order, and they'll be using a NoSQL to manage and organize personalized recommendation. So that is just the beauty of SQL and NoSQL to a context. Let's have some hands-on section, shall we? All right. So in this hands-on session, we're going to be practicing with MySQL Workbench, which is an RDBMS, and we're going to be using one of the practice data in that location, which is the Sakila database. Okay. All right. And this database is actually amazing because it has like lots of tables. Some of the tables are what you see on your screen. We have the table for actors. We have the table for, okay, trying to log into my MySQL Workbench. Okay, so we have the tables for actors. We have the actors information table, address, categories, city, countries, customers list, files, themes and themes actors and themes categories and all that. All of those tables we find in that database that we will be learning and practicing with. Okay, so let's get into the hands-on and let's see more interesting things about MySQL. I'm sure by now you're learning a lot and it's pretty much amazing. And that's the truth, because one of the things about all this is your ability to be able to practice and really have the hands on experience. And that's one thing DataSeries provide. We provide you on our DataSeries episodes with concepts and techniques. So I'm going to be applying some of all these techniques that we've learned to this experience. Okay, so let's start with a new a new script. This is an SQL. This is scripts. Yeah, this is a file. It's an SQL file. So first, let's say I want to see all the database that is located in this RDBMS. So I want to see. So to view, this is a comment. So we put a comment by putting hash and asterisk, no, forward slash asterisk. And then we write the comment. So used for commenting. Okay. All right, we can, and then we put another asterisk and forward slash. Okay, that's one way to comment. Another way to comment is using hyphen, double hyphen. So also used for commenting. Then I close it with the two hyphen. Okay, very important to know these two are the different ways we can comment on our SQL. Let me zoom in a bit so you can see better what it is that I'll be doing. Okay, all right, so I'm sure you can see my screen better now. So let's cook. Now, I'm going to be looking at some of the database that are contained in this DBMS. So to see the list of all the lists, all the database contained in this RDBMS. Okay. So I'm going to say show database. Okay. And if I run this, I get a list of all the database. So some of the database I've worked with are Operator Hub, Amazon, Information Schema, MySQL, New Schema, and all that. So that's for a list of the database. What if I want to see all the tables? So let's choose the Sakila database. Okay, I'm just going to do use Sakila. Okay, I'll do use Sakila. Okay, and with a colon, and then run it. Okay, and is that right? Yeah, so use Sakila. Look at my output. My output is always ticking with green. It means that I'm correct. At any point I'm wrong, this will flag an error. Okay, say for example, I change this to E and I run this, it gives me an error. It means it doesn't understand that. So I'll just return it back to what it was before. All right, now take note of my schema. Sakila has been darkened, it has been bolded because I'm currently on Sakila database. Now let's see some tables. So I want to see a list of all the tables that are there. So to see a list of tables, to see a list of tables in the database, okay, I'm going to close my comment first. Okay, I'm going to say show tables. Okay, show tables. And if I run this, I'll be able to see a list of all the tables in the circular database. Pretty amazing, right? Amazing. That's just amazing. Okay, so now we've been able to see that. Let's now practice a few things with SQL, shall we? Now, we're going to be practicing with this exercise here. So I'll just copy it. I have it built in for us to use. Okay, this exercise we're going to use is going to allow us to design this database. Okay, we're going to design this database from scratch, right? So there are many cases you can build a database, you can create your own, and you can use an existing, you can create your own tables. We're going to create our own tables and all that. Now, this is a exercise that we're going to be practicing with. So these are notes. Okay, so because it's a note, I'm going to put a comment around it. Okay, and then I'll come at the end and I'll put a comment around it too. So this is a comment. Now, something that you should know is that when we use the forward slash asterisk, it can allow us to write multiple lines of comments. But if we use the hyphen, then we don't get the chance to write multiple lines. Don't forget to put your space at the end of your double hyphen. Okay, so let's read this and let's see what we can do with this. So the exercise is Nexus has a database containing information about customers, employees, orders, and different branches in US. Okay, so you've been assigned to help the customer relation. All right, you've been assigned to help the customer relation department understand how their customers are transacting with their product. Okay, so I'm going to stop here because of time, but we're going to create another episode where we're going to learn more about this. So see you guys in the next episodes where we practice this exercise. All right, guys, thank you for staying through to the end, and do make sure to check out other episodes that are coming on our YouTube channel for a full practice of this episode. Thank you.